Today we are going to talk about the lymphoid system, immunology, where today's basic concepts and lecture is about that. Let's suppose a bacteria enters in a person's throat, and that bacteria is multiplying there and damaging the tissue. Then how our immune system will respond to that challenge of the bacteria? And while we will be studying how our immune system will respond to that challenge, we will be talking about the B cells and T cells and macrophages and other cells which are involved in lymphoid tissue and immune responses. Let's start the story from here. There's a beautiful man. Men are also beautiful at times, but they are only smart. Okay. Let's suppose a bacteria comes here. This is a bacteria, right? And this bacteria attaches with the mucosa, and then it starts multiplying. They start multiplying, and then this bacteria start releasing its toxins and start damaging the underlying tissue. Let's suppose I've enlarged this tissue. This is wall of the pharynx. This bacteria enters into wall of the pharynx and start damaging the local tissue. Is that right? When it will start damaging the local tissue, naturally body will try to defend itself against this invading, damaging microbe, right? Whenever tissue is damaged, we say there is inflammatory response. Whenever vascular tissue is injured, there is inflammatory response. During that inflammatory response, blood vessels dilate. Blood vessels which are going to this area, especially arterioles, they will dilate. So blood flow to this area will be more or less? There will be more. So that increased blood flow should bring more neutrophils, more macrophages, more lymphocytes, more antibodies, and more other components of the blood which can fight with the microbe. So what really happens, that as this bacteria enters into this tissue and start multiplying there and start damaging the tissue, right? Tissue response towards this injury is by inflammatory process. During inflammation, arterioles dilate and blood flow to this tissue increases, and microcirculation, that is capillaries which are lined by which cells? Endothelial cells. Endothelial cells undergo modification. What happens in endothelial cells? What happens to endothelial cells? That endothelial cells express special sticky molecules. They express special adhesion molecule so that the white cells, white blood cells which are coming into this tissue, they should stick to these endothelial lining. They should not simply move out. So what really happens? Tissue is injured, vasculature is changing there, arterioles are dilating, and in microcirculation and capillaries, endothelial cell becomes sticky for the white blood cells. So white blood cells start sticking to the endothelial cells. And as you will know later when you will study inflammation in detail, that white blood cells will come out from the vascular compartment into tissue. For which purpose? To fight with the bacteria. Which white blood cells come out first? Neutrophils or macrophages or lymphocytes? Who will tell me? Which are the white blood cells? Which type of white blood cells first of all come out during acute injury? Acute means short-term injury. Yes? Neutrophils. That's good. Neutrophils come first of all into tissue. Why? There must be a reason. Because they're most abundant, and because they're most motile, and because the substances which attract the neutrophils, they are produced first of all. Why the neutrophil first of all come out of vascular system into tissue to fight with the organisms? Because they enter first of all and in big number. Why? Because the number in the blood is more than the monocytes, more than the lymphocytes, more than the eosinophils, more than the basophils. Neutrophils are the most abundant white blood cells in the blood. This is one reason. Secondly, neutrophils are most motile out of all other white blood cells. Neutrophils are most motile. Number 3, the chemoattractive substances to bring the neutrophils out, chemotactic agent to attract the neutrophils are produced most early. That is why neutrophil will come out into tissue. So here the neutrophil which has come out to fight with the microbe. And once neutrophils start fighting with the microbe, they will call their friends, and they will call their friends which are more hardy, which are stronger. Which are those friends? Neutrophil will produce some chemical substances to attract a very special type of strong cells, hardy cells. What are those cells? The macrophages. That's good. Actually, they are monocytes. Monocytes are present in the blood, and when monocytes come out, they are called macrophages. So, suppose in this bacterial infection, when tissue is damaged, neutrophils come into tissue from the vascular compartment followed by the macrophages. Is that right? Now, let's see what really happens here. I will enlarge this area. Let's see what really happens here. I remove a piece of this tissue from here and put it there. Here was, let's suppose, vasculature, right? And here was a neutrophil out to fight. Always make neutrophil with multilobated nucleus. That's a sign of neutrophil. Whenever you make a cell, white blood cell, put multiple lobes in the nucleus, it is automatically understood all over the world you have drawn neutrophil. And when you draw the macrophage, make a cell with irregular boundaries but kidney-shaped nucleus. Actually, macrophage is a monocyte. You know, monocytes are one of the circulating white blood cells. When monocytes come out into tissue, they are named and called macrophages. Macro mean what? Macro mean big, phage mean eating. These are big eaters, macrophage. Of course, then doctors must be comparing it with some small eaters. Macrophage is a big eater. But there should be something which eats a little. They should be called microphages. If there are macrophages, there must be microphages. Macrophages everyone knows. Which are the microphages in the body? Of course, very good. Neutrophil the microphages as compared to the macrophages. Is that right? Anyway, they are out, and let's suppose this bacteria is a bacillus. Okay, we make it here, bacillus. These are the bacteria. Now, this bacteria is a bacillus, and these are bacterial. What are these? Bacterial antigens. These are bacterial antigens. Now, what will happen? Neutrophil and macrophage will engulf the bacteria. They will phagocytose the bacteria. Let's suppose this is a neutrophil, right? And this is a multilobated nucleus of the neutrophil. And it phagocytoses the bacteria. So bacteria is present within the neutrophil in its phagosome. And these are bacterial antigens. One bacteria has one type of antigens or many types of antigens? Many types. Every bacteria has many type of antigens. That is why we say microbes are antigenically mosaic. That is why against one type of bacteria, multiple types of antibodies can be produced. Why against one bacteria you can produce multiple type of antibodies? Because one bacteria carries multiple type of antigens. Am I clear to everyone? Right? So, but in my diagram I am showing one antigen. Okay, for your peace of mind I show multiple antigen. This is one antigen, this star is another antigen, this triangle is still another antigen, and this is another antigen. These are multiple antigens I am showing on this bacteria, and of course this bacteria is not happy. It has been captured, right? And not only it has been captured, this neutrophil will start emptying its lysosomal granules in this phagosome. What is coming there? Lysosomal product. Especially destructive enzymes, dangerous enzymes. Those enzymes will start digesting the, what is this? Bacterial components. Then oxygen derived radicals are also produced. So multiple destructive products are released by the neutrophil into the phagosome so that bacteria is attacked by this product and bacterial antigens are now free. These are bacterial antigens. And what will happen? Neutrophil will release these antigens free. Is that right? So suppose this was the neutrophil, it was fighting, taking up the bacteria, and it was digesting the bacteria into multiple small pieces, and bacterial antigens are released. They will drain into what? What is this? Lymphatics. In this area there must be lymphatics. So bacterial antigens will move through the lymphatics. And somewhere down they will drain into lymph node where there are which cells? Lymphocytes. Is that right? So these bacterial antigens, when neutrophil has taken up the bacteria, destroyed the bacteria, some of the bacterial antigens will be regurgitated from the neutrophil into tissue fluid, and these antigens through the lymphatics will reach to the lymph node where there are lymphoid cells. Is that right? But macrophage will deal with the bacteria in a different way. Macrophages, I told you, they are more advanced type of cell as compared to neutrophil. Macrophage are having a very special function. Not only they will kill the bacteria, not only they will bring the antigens of bacteria out of the bacterial structure, they will process the antigens and present the antigen to the immune system in a very formal and professional way. We'll talk about how the macrophage work, right? You know about neutrophil, it just took up the bacteria, disintegrated the bacteria and released its antigens. Now we'll talk about the very professional performance of macrophage, how the macrophage work. Let's draw one macrophage here, which happens to that it has engulfed this bacterium. So this is a phagosome, and this is the bacteria, and of course these are bacterial antigen. Again, bacteria has many antigens, but right now we will talk about immune response against single antigen. Let's suppose we just concentrate our lecture that how our immune response will build against star antigen. This is just an example. No bacteria has a star antigen. Is that right? So let's suppose this antigen, I call it star antigen. Of course, we must make anti-star antibodies. The whole purpose of this lecture will be that once star antigen is in your body, how your immune system build anti-star antibodies. So for this purpose, first concept is that neutrophil has taken the bacteria and then lysosomal enzymes are released into this phagosome. This up to now, this step is just like neutrophil, and these antigens are made free. Is that right? These are bacterial antigen. Right? But macrophage will not leave the story here. It is more sophisticated and professional cell. Let me tell you what macrophage will do very specially. Suppose this is the nucleus of the macrophage. In the nucleus of the macrophage, on the chromosome number 6, how many chromosome number 6 will be there in one macrophage? How many chromosome number 6 will be there? Yes, please. 2. One should be coming from mom, another should be coming from dad, I'm sure. Right? There's maternal chromosome and paternal chromosome. Right now we are going into molecular level. What really happens, this is suppose chromosome number 6 maternal and this is chromosome number 6 paternal. Anyway, on these chromosomes, on the short arm, there are a very special set of genes, a very special set of genetic material. Right? Now, let me enlarge this genetic material. This is the gene. This is the structure of gene. I have enlarged from there. This is a very strange type of genetic material, that the genetic material which is at the top, all the time it keep on shuffling. It keep on shuffling. It keep on varying. But genetic material at the bottom remain stable. It is just like that. You have a lot of cards to play, and in the bundle of cards, upper cards you keep on shuffling and lower cards you never change. Just like that. So probably these genes are playing cards over there in chromosome number 6. That this specific set of genes, upper genes are constantly shuffling and lower genetic material is stable. Now, if from this genetic material you make messenger RNA, of course from DNA you make RNA, right? If you take messenger RNA, this part of messenger RNA will vary from molecule to molecule. Listen, this is first molecule of messenger RNA we make from this genetic material. Now in this messenger RNA, this part will be the same, but this part will vary from molecule to molecule in different messenger RNA. Let's suppose that this genetic material shuffles 3 times in a given time. And if it is shuffled this genetic material 3 times, if you make messenger RNA, then first messenger RNA may be like this, second messenger RNA may be like this, third messenger RNA may be like this. Now all of them are having constant portion similar, but these portions are different from messenger RNA molecule to messenger RNA molecule. Are you understanding it? When they will be translating into proteins, you know, messenger RNA is translated into proteins. When they will make peptide chain, this was DNA, this is messenger RNA. From this messenger RNA, when we will make the protein, now these protein molecule from here which is derived, it may be like this. Protein molecule which is coming from here, it may be like this. Protein molecule which is derived from here, it may be like this. So what we really see, that this genetic material is leading to formation of messenger RNA which translate into peptide chains, and these peptide chains have constant tails but variable heads. Is that clear? Now you may be thinking why I'm putting so much stress on it. There's a reason for that. Actually, as soon as macrophage is activated, it start producing such molecules, these molecules, let's call them red molecules. It is constantly producing red molecules there. This is one red molecule, this is the second red molecule, this is the third red molecule, and so on and so forth. It is producing thousands of the red molecules. Now what is the function of these red molecules? Actually, these red molecules will be transported to this area. And every molecule will try to fit the antigen in its pocket. Sooner or later, by random chance, some red molecule will come over here which is able to bind with this specific antigen. Again, listen carefully. It means macrophage, through the special genetic operators in the chromosome number 6, they are producing special type of molecules, and these molecules are having variable area from molecule to molecule, and these molecules go and they are trying to fit with the antigen. Sooner or later, at least one red molecule will be generated just by chance which could stick with this antigen. And once the red molecules stick with this antigen, let's suppose this is the antigen, star antigen, and this is the red molecule. As soon as this red molecule fits into there, antigen will be considered a precious antigen. It will not be further destroyed. Because now macrophage has labeled it with a red molecule, and this antigen now is considered a very important piece of peptide, and macrophage will take these two molecules on its surface. Now these two molecules will move towards the surface of macrophage. Am I clear? This complex will come on the surface. What is very special thing about it? Special thing about this is that macrophage has decided that this antigen could be labeled in a very specific way. This labeled antigen along with this red molecule now should be presented to immune headquarters. Antigen has been processed. The technical term we use is that macrophage has done the processing of antigen. Is that right? Antigen has been processed. Now next step is this processed antigen should be presented to the immune headquarters. You see, macrophage is different than neutrophil. It did not just throw the antigen out. It handled the antigen, labeled the antigen, and now if I'm the macrophage, okay, this is the antigen, and this is, yes, this is the star antigen, and this is the red molecule, and I'm macrophage. Now I'm expressing these two things on my surface. What I will do? I will not throw this into lymph. Macrophage will personally start moving through the lymphatics. Where it is going? It is going in search of the lymphocytes and personally present this report. Right? Now, let's suppose that these are lymphocytes sitting over there. Of course, when macrophage will move through the lymphatics, it will also go to the lymph node. Lymph node has millions of the lymphocytes. Now, macrophage has personally come with the antigen, rather with the processed antigen, to the lymph node, and now macrophage has to present the antigen to an appropriate lymphocyte. It has to present antigen to an appropriate lymphocyte. Let's suppose that it is going to present this antigen to T lymphocyte. What are T lymphocytes? What are T lymphocytes? Which are T-shaped. T lymphocytes are the lymphocytes which has been educated and trained in thymus. Lymphocytes which are educated and trained into thymus. T for thymus. So lymphocytes which are thymically trained, they are called T lymphocytes, or simply call them T cells. And the other lymphocytes which are normally trained in the birds in bursa fabaceus, or in human beings, though other lymphocytes are trained and matured in bone marrow, they are called B lymphocytes. So there are T lymphocytes and there are B lymphocytes. T lymphocytes are processed in and mature, their maturation places thymus, and B lymphocytes in human beings are maturing in bone marrow. Is that right? Now, macrophage has to present this antigen to the T lymphocyte because some of the T lymphocytes are T helpers, because they will help some B cells to make antibodies. Let's see what exactly happened. This has come to the lymph node, and in the lymph node, now let's suppose this is that macrophage. This is that macrophage. Here is the, yes, antigen. Here is, this is antibody. This was the red molecule. Okay, should I tell you the exact name of the red molecule? These red molecules are called MHC class 2 molecules. Have you heard of these molecules? You will hear if you study histology from any good book. Yes. MHC class 2 molecules. Is that right? Now, why we call it MHC class 2 molecules? MHC stand for major histocompatible. M mean major, H for histo, C for compatibility. Let me tell you from where this name came. Let's suppose you put this person's kidney in my body. Do you think my kidney's tissue is self for me? My immune system does not attack my kidney tissue. But if you put some other unrelated person kidney in my body, my immune system will attack. It means his kidney tissue is not compatible with my tissue, with my own immune system. Again, listen. My tissues should be compatible with my immune system. My immune system should not attack my own tissue. But if you put Waqas kidney into my body or Gavin kidney into my body, I'm very sure that my immune system will attack the transplanted kidney. Why? Because their tissues are not compatible. Is that right? Doctors were always puzzled that why in some very close relatives tissues are more compatible, and from distant genetically unrelated people tissues are less compatible. Later on they came to know that as your thumbprint is very unique in the universe, the molecular thumbprints on every cell you have. On Dr. Najib's every cell, there are special molecular thumbprints which are recognized by my immune system as self and by other people's immune system as non-self. And Mr. Waqas Mr. Vakas, kidney, rather all tissues, every cell has some molecular thumbprints, fingerprints, molecular fingerprints, and those cells with those unique Vakas molecular thumbprints are recognized by his immune system as self, but my immune system as non-self. When doctors were looking what are these molecular signatures and thumbprints and fingerprints, they discovered these molecules. Right? That these molecules are responsible, they are special molecules which are responsible to make the tissue unique for every person. For example, Vakas has, if we bring some of the Vakas skin cell out, on his skin cell there are unique types of red molecules, and my skin cell there are different type of red molecules. Right? And those molecules determine the tissue compatibility. My red molecules are recognized by my immune system as self. His red molecules are recognized by his immune system as self. Is that right? And this is how immune system look for molecular fingerprinting on the whole tissue. Is that right? Now, these molecules were called the molecules which mainly determine histocompatibility in between the people tissue, person's tissue. So these molecules were simply called major histocompatibility molecules. Later on they discovered two classes of them. So we simply call them MHC1 molecules and MHC2 molecules. Right? Later on we discovered more functions of these molecules. One function of this molecule was to determine the histocompatibility, that tissues in one person are compatible with the other person or not. Let us suppose if they are two identical twins, their class 2 and class 1 molecules will be absolutely identical. But my class 1 and class 2 molecules should be very different from class 1 and class 2 molecules of Vakas. Is that right? So our tissue then are not considered compatible. We have histo-incompatibility. Is that right? So these molecules were called MHC molecules, or major histocompatibility determining molecules. Later on we discovered these molecules have some other functions. One of the very important function is that class 2 molecule, now I will not call them MHC class 2, in lecture I will simply refer them as class 2 molecules. These class 2 molecules also are used by macrophages and other antigen presenting cells to label the antigen as foreign antigen. Is that right? Am I clear from where these molecules came, MHC class 2 molecules? Of course, no fun in telling their genes are present on chromosome number 6 anywhere. So macrophage make lot of MHC class 2 molecules, and with every antigen they have, eventually sooner or later some class 2 molecule fix, then antigen along with the class 2 molecule is expressed on the surface of the macrophages. Then macrophage in person go to the lymphoid headquarters. They want to present to the immune cells which are lymphocytes, hey, I have this antigen, and you see I have processed it. Now you do something about it. Is that right? Now, look, when this will come into lymph node, let's suppose macrophage is here. Now there are many lymphocytes or only one lymphocyte there? There are many lymphocytes. What it will do, let's suppose these are the different lymphocytes. Now look, I'm showing here in the diagram 5 lymphocytes. Macrophage, you will be so surprised to know how beautifully your body works. Every lymphocyte is pre-programmed to react and recognize only a unique type of antigen. Listen carefully. Every lymphocyte is already pre-programmed in your body to recognize and react against a unique antigen. There are millions and millions of the antigens in the nature. Of course, in your body there should be millions and millions different type of lymphocytes which should be able to recognize different type of antigens. Let's suppose, how do they recognize the antigen? They have molecular eyes, molecular things. How? Let's suppose this is a special molecule in lymphocyte number 1. This is another molecule which is on the lymphocyte number 2. This is another molecule which is on the lymphocyte number 3. There is still another molecule which is on the lymphocyte number 4. And there is another molecule which is on the lymphocyte number 5. Do you think these surface molecules are identical or different? They are different. Actually, they are programmed to react with different antigens. Is that right? For example, this is pre-programmed to react with star antigen. This is pre-programmed to react with this antigen. This is pre-programmed to react with this antigen. This is pre-programmed to react with spherical antigen. And this is pre-programmed to react with different antigen. Now look at the beauty. That right now in your body, there are hundreds and millions of the types of cells, or I should say there are lymphocytes, and these lymphocytes are having, these are called antigen receptors because they receive the antigen. What should be they called? Antigen receptors. And I will soon tell you, if these lymphocytes are trained into thymus, then these are called T cells. And then these molecules, look, these molecules, they should be called TCR, T cells receptors. Now, in further discussion, if I say TCR, you should immediately understand that I'm talking about antigen receptors present on T cells, right? Now, on a given T cell, on one T cell, all the antigen receptors should be different or same? Same. One T cell may have thousands of the receptors, but all of them are absolutely identical. But different T cells will have receptors which are different. And due to the, as different T cells have different TCRs, that is why different T cells are pre-programmed to recognize same antigens or different antigens. Different T cells are pre-programmed to recognize different antigens. Is that right? It is just like that there are 10,000 married women, truly married women. They are somehow, due to virtue of their marriage, they're pre-programmed to recognize a different man as their husband. Or do they get confused? It's just like that. T lymphocytes are trained in the thymus actually. And in the thymus, their genetic material is programmed in such a way that every T cell expresses a unique type of TCR, and it gets programmed to recognize a unique type of antigen. That antigen may come repeatedly into your body, or that antigen may never come. You know, luck matters in so many things, including the T cells. Right? Now, what this will do, this cell will do, macrophage. What the macrophage is going to do? It is having the antigen and process with what? Class 2 molecule. I'm the macrophage. Go back. This is the antigen and this is the class 2 molecule. Now, I will go to lymphocytes. I will present this antigen to every lymphocyte until I find a lymphocyte which recognizes this antigen. Are you clear? Right? Let's suppose these are lymphocytes sitting there in the lymph node. I'm the macrophage. I come over there. I'm very proud I have processed the antigen, and you should be happy I personally come, not like neutrophil throwing the antigen to the lymph node. Personally coming. What I'm doing now, I'm going to lymphocyte. Bring your one hand forward. This hand is supposed to recognize this antigen, right? Yes, catch this antigen. And with the other hand, lymphocyte has some sort of, very, very fussy. It has to check the antigen came with proper processing with class 2 or it came without that. So with the other hand, he will check the processing is there or not. Are you understanding? So this molecule, which recognizes the antigen, right, and this molecule recognizes the presence of class 2 molecule. Is that right? Let us suppose this molecule which recognizes the antigen, this is his TCR, T cell receptor for the antigen. Let's suppose he is unable to grip it. Right. Okay. I will come here. Let's suppose, actually macrophage has to go, this is the problem. Lymphocytes are not supposed to come. Sit there. This is the problem of the camera. Listen, okay, we'll go to some other lymphocyte. Right? We go to this lymphocyte. Look, she has, this is her TCR, T cell receptor to recognize the antigen. And this is her another molecule which is supposed to check that is the antigen properly process with class 2 or not? Because T cells do not attend the antigens without class 2 molecules or without class 1 molecules. T cell recognize only peptide antigens and only those peptide antigens which are processed with MHC molecules. That is why in the books you will read T cells have MHC restriction. They are MHC molecules restricted cells. What does it really mean? It means that they only recognize the antigens when they are properly processed with MHC molecules. Am I clear? Now, yes. Let's suppose our TCR does not adjust well, so no need of checking this. Now I go to the next lymphocyte. I've gone to many lymphocytes. Up to now, no lymphocyte TCR was able to interact with it. So I just present the antigen here, then present antigen to another lymphocyte, then another lymphocyte. I become a sort of antigen presenting cell. That is why macrophages are called antigen presenting cells. The short name of macrophages, they are one of the APCs, antigen presenting cells. Macrophages are also called, not only they are phagocytic, they are also antigen processing and presenting cells. And they have their other friends also. With the macrophage, there are some dendritic cells which also do antigen presentation. B lymphocytes can also do antigen presentation. Langerhans cells can also do antigen presentation. For a while you just concentrate the macrophage are antigen presenting cells, right? They process the antigen with class 2 and now they go to lymphocyte and try to fit the antigen into lymphocytes TCR molecules. Okay, I reach up to this very good lymphocyte and I try, okay, come up at least. This is another lymphocyte, macrophage has reached there. Yeah. Oh, good. And antigen has been very properly fit into TCR. Immediately T cell will become happy. Okay, T cell feel the antigen against which I was programmed, that antigen is there eventually. Because this T cells, TCR, T cell receptor is properly loaded with the antigen. Its immediate concern is that it should check that antigen came with processing or without processing. So T cell should have some mechanism to check the presence of which molecule? Class 2 molecule. T cell bring another? Yes. And this molecule of the T cell could check the presence of class 2 molecule. Now, there are antigen recognizing unit, antigen recognizing molecule on the T cell surface, and there is class 2 molecule recognizing molecule. This molecule is called TCR, and this molecule is called CD4. This is called CD4. Let me tell you. Thank you. You just sit there. Let me tell you that, yes, suppose this was the lymphocyte, and on this lymphocyte, antigens were fitting into this. So what is this? TCR. And then this was expressing one more molecule which could recognize the presence of class 2. And this molecule is called CD4. Now you may be thinking why it is called CD4. Actually, doctors in their early experiments, they discovered that different clusters of T cells had different functions. Different clusters of T cells had different function. And they came to know different clusters of T cell express different surface molecules. So they designated the clusters of the lymphocyte or different clusters of lymphocyte and other cells according to the proteins expressed on the surface. So for example, the protein which was present on cluster number 1, they call that this cluster has cluster designation, CD1 protein. Then another cluster of cell had CD2 protein. In this way, on different clusters of cell, they found different special surface proteins and they call them cluster designating proteins. Is that right? In the same way, in some lymphocyte, they found a protein, and at that time in the laboratory, they labeled that protein as cluster designation protein number 4. They never knew anything else about this protein. Now we know that CD4 protein is present on the surface of the lymphocyte to recognize the presence of class 2 molecules. They are class 2 sensors. MHC class 2 sensors. Now listen again. TCR is a antigen sensor. CD4s are, yes please, class 2 sensors. Is that right? Both sensors should be fully satisfied. If both sensors are fully satisfied, only then both of them will stimulate another group of protein, and this protein will give signals, and that signal will go to the nucleus of lymphocytes. They will send the molecular signal to the nucleus of lymphocyte. What signals will go to the lymphocytes nucleus? They will tell the nuclear machinery that the antigens against which our cell was programmed, that antigen is there at the door, and it is properly processed with class 2 molecule. Let's start building some immune response. It means some bacteria in the body, and we are programmed to react some response and orchestrate some response against that particular bacteria. So there were many lymphocytes. Let's suppose only this lymphocyte could recognize the antigen, star antigen. Do you think all of the lymphocytes will be selected for action, or only one will be selected for action? Only this will be selected for the action, because macrophage may go to others, but others will not. Others, TCR will not interact with the antigen. So it means there are 5 clones of lymphocytes, and antigen has only selected one clone. So macrophage bring the antigen with proper processing with class 2 molecule and present the processed antigen to many lymphocytes. Eventually, one clone of lymphocyte is selected for the action. You understand which clone is selected? Where TCR can accept the antigen. Is that right? This process is called clonal selection. This process is called clonal selection. Is that right? Now clonal selection of the T cell has been done. A T lymphocyte has been recognized. Let's suppose these were 1, 2, 3, 4 and 5. Out of that, this was selected. Now what will happen? This will give signal to the nucleus that happy news, the antigen with proper processing is at our door, and let's get ready for the action. We'll see what is the action. Is that right? Now, actually, when message is going to the cellular headquarters, it's a new relationship developing. You want to activate this lymphocyte. Is that right? If you really want to make someone happy, you want to activate someone, you will take the gift to the person. And gift should be properly presented or just thrown? Properly presented. So macrophage has brought the gift of antigen with proper presentation, and gift has been accepted by the T lymphocyte and also happy with the presentation way of with class 2. Now macrophage has to do some more thing. It's not enough that you just give a properly processed gift. You have to talk to the cell. Macrophage, meanwhile, once they come into touch with the cell and this molecular interaction is going on, macrophage start releasing another group of molecules. Okay, just like that, you are trying to talk to a girl. You give her a gift. You are giving her a gift, and what is this? And properly presented, and she is happy. She accepted the gift, liked the gift, happy with the presentation, and she gives message to her parents that there is someone important around. Right? Probably I'm predetermined and pre-programmed by God for this person. And if person remains shut up all the time, person remains like this, do you think this will be activated? No. Person will talk, molecular talking. So what will happen? After this initial selection process, macrophage is, very, very clever cell. It will start releasing some other molecules, which will further stimulate lymphocyte. And it is ready to be stimulated. It is having its receptor. This is communication between the two white cells. This is a communicating molecule between the two white cells. White cells are called leukocyte. So this is a molecule which is intercommunicating molecule between two leukocytes. This is called interleukin. And in our discussion, you see it is the number 1 interleukin appearing. We call it interleukin 1. So technically we will say that once the macrophage has successfully presented the antigen to the proper T cells, then macrophage start releasing what? Interleukin 1 molecule. Interleukin 1 molecule stimulates the receptor for interleukin 1, which is present on lymphocyte surface, and this receptor also gives signal to the headquarter. Not only gift is there, sweet talk is also there. Is that right? Now macrophage is also encouraged, happy. Relationship is advancing. What it will do now? Yeah, wrong things come into your mind. His eyes start shining. What do you think? What macrophage should do? Okay, Gigi will tell us. Yes, what macrophage should do now? His gift has been accepted. Ladylike T cell has also liked the presentation or wrapper of the gift, I must say, and very happy and informed to the headquarter. Then there's some sweet talk, right? That also help in further stimulation. What the macrophage should do now? He will develop a personal contact, physical contact. It's very strange how the molecules in cell interact. Now, this brings one more molecule out. Who knows the name of this molecule? And this will adjust with one more molecule which is already present on the surface of, okay, I'll make it different color so that you don't get confused. What will happen? That a very special contact molecule, it is not released like interleukin 2 was released, but this molecule is not released, and of course this molecule's receptor is also present on the reprogrammed lymphocyte. Now macrophage will express one more molecule which will stimulate another receptor on the T cell, and another message going to the headquarter. Headquarter will get overwhelmed until it start reacting to the situation. I will tell you how it will react. What is this molecule called? B7, that is good. This is called B7 and this is called CD28. I think it was discovered on 28th sequence. So B7 should react with CD28. Now you may be thinking, what's the fun to know all this thing? Let me tell you one thing. They have now the drugs which can block this pathway. They block drugs which block this pathway. Do you think then T lymphocytes will work? No. So drug will be immunosuppressor drug. They suppress the immune response by T cells. And they are planning that if they can utilize this molecule or block this system, they can control the actions in the immune system in certain diseases. Is that right? Now, this is the primary interaction and this is called co-stimulation. This was the primary stimulation, isn't it? And this is called co-stimulation. This is antigen and TCR is called first signal. Antigen with TCR is called first signal. And B7 with CD28 is called second signal. To activate the T lymphocyte, we need first signal as well as second signal. Are you understanding? Second signal shows there is ultimate commitment for the action, right? And then T cell become really active. What this T cell will do? It will become very happy that out of so many lymphocytes I have been selected and I have been co-stimulated and I have been specially, you can say, given attention. What this lymphocyte will do? It will activate its nuclear machinery. Let's see what it does. It will activate, suppose gene number 1, I'm putting myself the gene number 1 and gene number 2. Gene number 1 will produce the, of course, messenger RNA and then proteins, and those proteins will go out. These are the protein molecules which are being secreted now by selected lymphocyte. This lymphocyte becomes different than other lymphocyte. It starts secreting special type of molecules. Happy, isn't it? Now, so here you are laughing. Are you? I say this lymphocyte is happy and starts secreting a special molecule. Why it made you so happy? Not happy? Okay, I thought maybe it's special cause of happiness. Okay. Now there's another funny thing. It starts releasing this red molecule. Attention please. This is gene number 1 and here is gene number 2. As gene number 1 is producing the product and secreting the product, gene number 2, it's so interesting thing, start making a protein, and that protein is not secreted. That protein is stuck into membrane of this cell. Is that right? Now you may be thinking what these two genes are doing and their products are doing. Let's see. Then this happy molecule come and fit in here. And as soon as the first molecule stimulates the second molecule give the ultimate happy signal to the nucleus and stimulate a set of genes which are concerned with mitosis. They are concerned with mitosis. And once these genes are stimulated, this selected T cell, which has a TCR against this unique star antigen of that bacteria, the selected T cell start mitosis process. And all other T cells are just standing like this. But the single T cell start, what? Multiplying. It becomes thousands and then millions, right? We say that selected clone has expanded. What do we say? Selected clone has been, yes please, expanded. And this process is called clonal expansion. So this was the process of clonal selection and expansion during immune system activation. So now you see the T cells which were having such TCR which could interact with star antigen, that T cell has multiplied itself, right? So in our body now or in our lymph node, these anti-star T cells are less or more? They're more. So they were clonal selection process and they were clonal expansion. Now look. This molecule which was secreted by the lymphocyte on activation, right? What is the name of this molecule? This molecule is called interleukin 2. This is called interleukin 2. And what should be this molecule called? Interleukin 2 receptor. So when you will talk in a professional way, up to now, let me tell you, whole this thing which I explain, let me narrate now in a very professional way. What we should say, that bacteria entered into your throat, it started multiplying, damaging the tissue, inflammatory response built, blood vessel arterioles dilate, microcirculation endothelium become sticky to the white cells. White cells come into tissue. Neutrophils are first to come, followed by macrophage. Neutrophil phagocytose some bacteria, destroy the bacteria and release their antigens free into fluid, and these free antigens keep on draining through the lymphatic system into draining lymph node. Clear? Meanwhile, macrophages are more professional in handling the antigen. Macrophage initially also phagocytose the bacteria, break down the bacteria into antigens, but they process the antigens with which molecules? Class 2 molecule. Antigens, once they are processed with class 2 molecule, these antigens are expressed on, yes please, these antigens are expressed on surface of the antigen presenting cell of macrophage. This is the antigen and this is the class 2 molecule. Now macrophage through the tissue fluid will drain into lymph nodes through the lymphatics. In the lymph node, it will go to different T cells. To every T cell, this antigen presenting macrophage will present the antigen and try to fit the antigen to the different T cells TCRs until it will find one T cell where antigen can be, yes, antigen can be recognized by TCR. As soon as antigen is recognized by the TCR, right, then CD4 molecules of the T cells confirm the presence of plasto molecule. Once TCR and CD4 both are properly occupied through the CD3 signaling system, through multi-molecular pathway, they give signals to the nucleus. At the same time, there is additional stimulation. For example, macrophage release interleukin 1, they also give extra stimulation. Moreover, especially B7 from the macrophage interact with the CD28 of the T cell, and that also gives signal to the nucleus. Then genetic nuclear machinery is activated, especially two genes are activated in this selected clone of T cells. Number one, the gene which lead to secretion of interleukin 2 molecule, and number two, gene which lead to expression of interleukin 2 receptors. So secreted interleukin 2 molecule act on the same cell's receptor. It's like autostimulation. Even cells can do autostimulation, right? So this autostimulatory pathway is called autocrine pathway. This is called autocrine, right? So interleukin 2 through an autocrine pathway is coming out of the selected T cell and keep on acting on the same cell, right? And then interleukin 2 receptors, when they are activated by the interleukin 2 molecules, they give signals back to the nucleus to activate the genes which orchestrate the process of mitosis. And this particular lymphocyte which was previously selected, now it undergo proliferation, right? And it proliferates a lot, or it undergoes mitotic repeated mitosis, and in this way this lymphocyte, due to mitotic divisions, has an expanded clone. Is that right? Any question up to this? Let's have a break.